Santi, wonderful to have you here.
Hi, Ian. Nice to be here.
Hello. So we're delighted to have Santi Pal here. Santi is a mining engineer with 25 years experience, held senior roles, Rio Tinto, other mining companies. Really looking forward to our conversation.
Yeah, likewise.
Yeah. So tell me a bit about yourself. Tell me a bit about your background and how you got into mining.
Sure. So Ian, I actually grew up in India many decades ago, and but spent most of my time working life and career in Australia.
Yeah.
It's recently that I've moved to Singapore with my wife and enjoying this wonderful country, particularly the diversity and the different culture experience. It's been fantastic. From a work background, most of my working career has been with large mining operations in Australia in different commodities. Certainly the last 20 odd years been with a multinational company having had footprint across the globe in various different metal and minerals. Since moving to Singapore, it's been quite interesting actually observing the growth, particularly in the mining industry space, particularly around nickel and other battery minerals. So as the world grapples with how we can reduce our emission, some of the minerals and metals that is present in the Southeastern Asian countries comes to the fore. Love working with people. I enjoy the challenges that the mining industry presents and the opportunity to really work with partners across the globe in tackling some of those challenges is what makes me get out of bed every day. So
fantastic.
Looking forward to the conversation and discussion today.
Yeah, yes, me too. So tell us, what is a mining engineer? What do they do?
Well, it's interesting. A mining engineer, it is a professional qualified discipline. And the main task of a mining engineer is to safely and responsibly extract the valuable metals and minerals that we need to really sustain humankind. That's what a mining engineer does. It designs, identifies, particularly from geologist assistance around what is actually in the ground, and then through various means of planning, designing, extract responsibly that material, and then actually presents it to customers who can actually use it downstream for the material that we need.
So what is an ore body, or what is that material in the ground, and how does it get there?
Yeah, so majority of the material and minerals that we actually mine forms in the Earth's crust, and that material and metals comes in various forms. When there is a concentration of that metals and minerals, it actually is termed as an ore body, and it's that ore body that is then assessed for whether it has enough valuable material and minerals that you can sell, covering for all the costs and returning to the investors. So ore body is really a concentration of metals and minerals in a location. Sometimes there are ore bodies that really you can't mine because of various restrictions. For example, uranium mining is restricted in certain part of the world, and therefore, yes, there is a valuable resource there, but it's not until you're actually allowed to mine. And then there are other areas where you can actually mine responsibly, making sure that you can cover for all the regulatory and safety rules and regulations.
Yeah. So you've probably done a lot of work around resources and reserves. Tell us a little bit more about how that system works, how it comes about, and the uncertainty that's sort of bound up with an ore body, knowing what's underneath the ground and whether that might be economic to extract.
So, maybe taking a step back before we get into defining ore reserves, I think it's interesting to explore the connections that mining engineers have with the rest of the community, particularly, from an engineering standpoint. So I think I mentioned before the geology area. The geologists typically define the size and shape of ore bodies. And mining engineers do the necessary design, schedule, and extraction sequence using equipment and also the extraction methods. And then there is the metallurgists that actually take the material and turn it into a product. When you link that all together, you're effectively taking a resource and converting it into a product. And the mining engineers take the mineral resource that a geologist would define and then turn it into what's called a ore reserve. And the ore reserves is a very important feature of any mine or mining company, because it's the material that is, from a both quantity and quality perspective, is defined such that any person that actually comes across an ore reserve statement can actually assess the viability of that project. So it's actually very important from most of the stock exchanges around the world have specific rules on how an ore reserve is to be reported. And mining engineers have the task, particularly with the level of experience and knowledge on a particular commodity, that enables them to essentially sign off on the ore reserves. The ore reserves have various different subsections of an ore reserve. So, if you look at the ASX, the Australian Stock Exchange, its reporting of the resource is in three categories. So inferred, indicated, and measured. And when you actually convert it into a reserves, that converts into proved and probable. So measured resource typically converts to proved. The probable reserve is a combination of measured and indicated, depending on how much knowledge is there and confidence is there in the conversion. And inferred resource actually never gets reported as an ore reserve from a ASX standpoint. Again, it's to show your investors and stakeholders what is actually economically can be extracted and what's the certainty around that extraction.
Yeah, no, fantastic. So a few questions there.
Yeah.
So coming from an economics background, trying to understand a bit more about resources and reserves, am I right in thinking the inferred, indicated, measured reflects increasing geological certainty? And then when we move over to reserves, we're thinking about modifying factors, economics, legal, maybe logistics.
Yeah, spot on, Ian. The geology quantification of a resource is based really majority of the time based on drilling density. So when you have an ore body, you need to understand what's in the ore body. So to define the quantity and quality, we have to do a fair bit of geologists typically do a lot of drilling. And that drilling will give you the information to define closely the size and shape of the resource. Now, that's one thing. Where it is and how you're going to economically extract it is a task of a mining engineer, because you have to apply, as you quite rightly said, the modifying factors. And so some of the modifying factors are, for example, what is the geotechnical, which is really about the stability of your walls in an open pit mining environment. How are they going to behave when you extract it? So if you dig something out and the walls are too steep, there's a good chance it's going to fall down. And if it falls down, it's a disaster for a mining operation or a company. Not only the people who are working there will get impacted significantly or injured, and dare I say, in some cases we've had fatalities resulting in wall failures, or in other times you actually have to dig that whole material out, which is additional cost and the like. So a modifying factor is really those aspects that helps translate that resource into a mining entity. So those give you more confidence about the certainty of how you could extract the material safely and responsibly.
And I had some knowledge of the economic modifying factors, but I didn't know about the geotechnical piece. So I always thought of reserves and resources in terms of tonnage and grade, but perhaps it's shape and, as you say, geotechnical that also comes into whether that's an economic ore body or not.
And further down the track, you've got to actually be able to sell it.
Yes.
So if you don't have a customer for the material, then you cannot actually quantify something, or now or into the future. The market is an important factor in terms of being able to classify as ore reserve. Likewise, the metallurgy. So if the recovery of the material that you mine is impossible in the current technology that you can apply, then the actual ore body will remain quantified as a resource and will not convert into a reserve.
Yeah,
there are exceptions, but largely that's the method that's used.
Yes. So thinking about geologists, that they like rocks, obviously, and that they're interested in how minerals are formed in the ground over time. And then metallurgists are they concerned with, say, standards and what the properties are of the product that comes out? You got process engineers. So is a mining engineer? Do they fit in? Are they part of, I guess, stages where you look at different parts of the mine or the mining process, or does a mining engineer thread those things together? Is it the connective tissue between geologist, metallurgist, process engineer? How do you see it?
It's a nice way to describe it. In a way, it's like a bit of a glue in that whole of the value chain that starts all the way from exploration through to the customer. And then if you look at an operating mine, it's from, again, the pre-mine development through to closure of a mine site. Mining engineers typically have an oversight of all of those areas, mainly because they're the ones who are creating and constructing the mine plans.
Yes.
And the mine plans is a combination of all of these aspects coming together. There is no doubt that those few disciplines that you mentioned, and then there are many other. There's many support functions that are also vital in a mining operation organisation, such as human resources, legal, commercial, as well as health, safety, environmental, policymakers, etc. But when you look at a extraction of a resource, the ones that are on the upstream side of mining, which is the geology and exploration, and then downstream, which is your process and metallurgy, they play a very, very strong link for understanding how the ore body is behaving when you actually mine. So, and part of that understanding is reinforced through what we term as reconciliation. So it's quite an important feature of any mines, that systems and tools have to be put in place such that you can actually reconcile against your plan. And then from that reconciliation, you can start to make some prediction as to how this mine is going to perform and behave into the future. So those disciplines work very closely together. Sometimes a fair bit of debate and tension because everyone's kind of saying, hey, it's to do. The metallurgists will say, mining engineers, what is this ore type that you're giving us that we can't extract or getting the right recovery? And mining engineers typically say, well, that's the best knowledge we have. So we've, this is what we have. So therefore, this is, we have to find a way of getting it through the plant. So very, very close communication dialogue has to be maintained between all of those disciplines to ensure that we get the maximum value out of our resource.
Fantastic. And what is the value of those resources? What are minerals used for? How are they integral to our everyday lives?
Yeah, Ian, it's interesting. Mining industry doesn't necessarily have the level of deep understanding outside of some perhaps unfortunate incidents that often takes up a lot of the limelight, particularly around environmental and safety incidents. But mining is essential. It's everything that we pretty much use on a daily basis comes from extraction from the ground, whether it's on surface in an open pit or deep underground, and it's ever present in pretty much everything we do. Our mobile phones, our laptops, our power that we generate, where we've got copper wires running through our houses. You've got big buildings you've got cities effectively being built in the likes of China, where majority of the steel has come from iron ore out of either Australia or Brazil or other countries. So you everything we touch and feel, unless it's something that we're eating, but even the stuff that we eat, food, the fertilizer that is used is actually phosphate that comes from the ground. So the connection with the earth and what we touch and feel in everyday life is very real, but not well known.
No.
So the mining industry has always have had challenges in being able to promote the requirement of mining for not only existing but improving and sustaining future mankind progress.
And the global nature of it fascinates me as well, in that whether it's an air conditioner that has aluminium in it, that aluminium might be extracted as bauxite in Australia and refined into alumina, but then smelted somewhere else in the world, whether that's China or Iceland or Canada, and then with the copper value chain, you could have wires that come from Chile and are smelted in a different part of the world, and lots of minor metals as well, right? So from everything from cobalt to nickel in batteries, which have very complex value chains, and they're very specialized, and different parts of the processing happens in different parts of the world, and they end up in our everyday items that we take for granted.
Sure, and you touch on a really good point there. It is something that we don't necessarily delve into too much, is the complex supply chain. This global nature where you've got raw material coming from one part of the world combined with processing in another part of the world, and then through logistics and supply chain, we deliver that product to customers that might be another part of the world. So to tie that all together, it's quite complex. But the stuff that is tying it all together, the material that we, the equipment that we use to mine, the trains that we use to, and the trucks that we use to transport, and then the ships that we actually take it to other part of the world, and then to eventually build the same things again. It's all kind of a circular sort of aspect, which mining is actually at the center of all of that.
Yes.
So it's ever present and required. Yes.
Yeah, you need steel and copper and aluminium to undertake mining itself.
Definitely,
right?
Definitely.
But I guess you've spent a sizable proportion of your career in the bulks, and I think it's very difficult to appreciate how the scale of that industry. So that there's some metal industries which are much smaller, maybe 10,000 tons a year, maybe 100,000 tons a year. But the iron ore industry is of a completely different scale, right? And a feeder for the steel industry. So tell us a bit more about iron ore, and I guess maybe how can we help our audience understand the scale of this industry
Yeah,
and
okay.
the impact it has on the world.
Yeah, I've been very fortunate, Ian, to have spent a large portion of my working career connected with the iron ore mines. Later in the career, I had more of a global role around the technical area of mining. Majority of my working career has been based out of Perth and connected with the Pilbara region. So let me just explain where Perth. So Perth is in the west coast of Australia, which is a very large country. And then from there, about 1,500 kilometres north, is a town called Tom Price. And Tom Price is actually in the heart of the Pilbara region. And it is an iconic town, dates back to the mid-60s, where the first iron ore mines were started in the Pilbara. I was very fortunate to actually live and work in Tom Price for a couple of stints, going back a few years. So Pilbara produces a lot of the iron ore that the world consumes, and it's several mining companies operate in the Pilbara, and there are many operations, many mines. So the one particular organisation I worked for had 16 mines, and now it's up to 18. And it has an integrated network of mining, and then through a rail network about 280 odd kilometres away, going to several ports in the northwest part of Australia. So we're talking about something that is a massive scale. And these mines produced in the order of 1+ billion tonnes of material every year.
Yeah.
So a tonne of material is 1,000 kilograms. So you can imagine how much material is moved on a daily basis, all around the globe, around the clock. So it's 24 hours mining, and it actually provides this material to through first of all the equipment to mine, and then you've got your rail, and then eventually with ships transported across to other parts of the world. The system is integrated, and it's not just the company I worked for. There are other companies also operate in smaller hubs or small consolidated operations. And most of those are actually managed through operating centres, which are typically located out of Perth. So this whole system is quite modern in a sense of technology advancement that has taken place, particularly over the last 20 odd years. A majority of them operate with autonomous trucks haulage. So we're talking about trucks that are more than 220, 240 tonne trucks. Some of them are more than 300 tonne trucks. So these are massive, big units, but they're self-driving and are operating autonomously. So we have a system that is, technologically advanced, and it is working in a very seamless and smooth and consistent way, producing the steel, the iron ore that the world needs. That's then converted into steel.
Okay, we'll come back to iron ore and steel in a bit, but I noticed you mentioned that you lived in Tom Price.
Yes.
So tell me a little bit about what it's like to work in the Pilbara.
Hot. It's hot. It's a warm place.
Yeah.
But what makes it exciting is that the magnificent and the natural beauty of the landscape is stunning. You've got some wonderful ranges. The Hamersley Ranges is quite a well-known area where people tend to go and visit, particularly in the cooler winter months, so that they can actually, enjoy the beautiful gorges and the landscape. But Tom Price is a small town, a mining town. At the time we were there back in '96, and then again in 2008, we're talking about 1,500 odd people live in the town, and there's a lot of people who come into Tom Price to service and support the town. And in the second stint, there was more of the fly-in, fly-out type support and service teams, whereas in the early days, it was very much living in Tom Price. So you can imagine that when you're actually 1,500 kilometres from Perth, it can be quite an isolated town. But what made it very, very enjoyable was the community. And I think this is, again, one of the things that organisations have to appreciate and take real interest is, mines are not always located close to major towns and cities. And so having a footprint in very isolated locations where you may have vulnerable communities, Indigenous communities close to it, means that engagement with those communities is vital. So having a presence at that mine site and living there and actually understanding how a mine operates and what are some of those challenges, first-hand experience was truly a privilege. So for a mining engineer, being on a mine site actually is really important. You can't really do a lot of mining sitting in an office. You can do aspects of it, but to really understand what's going on, got to get on the ground. So,
yeah, got it. And so, when we get on the ground, what does that look like? I guess in the mining, in the iron ore mining industry. Tell us a bit about the different processes that you go through to extract a ton of iron ore and get it to market.
Yeah, I touched a little bit on those various parts of that value chain of mining, starting from exploration, then development, planning, production, and then through to processing, and then across to the customers and stockpiling and the port, etc. But if you look at the act of mining, there is various stages. So you've got to understand what the mine plan looks like, or a schedule. So I'm a great believer, and so is most mining companies, that your success really depends on the actual quality of your plan. And the quality of the plan depends on the information that goes into the plan. So a mining engineer starts off typically with a strategic plan, a life of mine plan. And then as you bring those time frame closer together, it all comes back to almost what's going to happen in a day. And then inside a day, what's going to happen in a shift. And so in a shift, which is typically a 12-hour time period, there will be a case of, this is the amount of material that we're targeting at a particular grade. And then how would you actually schedule your equipment to enable you to extract it? And it's not just equipment that's been used to do the extraction, like your drills, production drills that is used to drill the holes, fill it in with explosives, blast it, and then you have your excavators that dig it, take it on a truck, and then send it to a crusher, and then through to the process plant. That's kind of the mining aspect of it. But then there's all this other equipment that has to be maintained. So you've got to actually schedule the maintenance of your equipment at the same time as you're operating the mine. So the schedule takes into account all of those aspects that enables you to mine and to deliver the material to your process plant on a daily basis. And you're not really just dealing with the ore, which is the metal that's of value. No parts of the ore body comes out. No ore bodies are developed with just the metal and the ore. So they're associated with some waste material that also has to be extracted such that you can, deliver the ore. And that's actually typically termed as a strip ratio. So here's another term introduced on mining, is when you look at ore reserves, yes, you've got all your tons and grade of the material that you mine, But when you're actually talking about a mine plan, you've got to deal with strip ratio, which is both ore and waste. So not only are you planning to dig out the ore, you also have to then say, I'm going to dig out some waste that is not going to the crusher, but has to go to waste landforms. Okay, well, where is it? How far is it? So a mining engineer's job is to really optimize the flow of material from the source to the various destination. That's what typically someone would do on a daily basis or a shift-by-shift basis. So we're getting quite deep into this topic, but fire away.
It's fascinating for me, and I think more of my experience has been on project development and investments, and so the mine plan there is perhaps over 10, 20 years, and I hadn't appreciated that these longer term plans are then scaled down or divided up into much higher frequency year plan, I guess quarter, and then right down to the shift level. So that's fascinating, and very interesting to know how that works. You able to tell us more about blasting, crushing, grinding? What does that look like in the iron ore business, and how does it differ perhaps to copper and other materials?
Not so much in terms of the processes that you go through. I think that most of the bulk mining or even base metal mining sort of resources are carried out as a very similar way, where you have your production drills. We talked about drilling in the past, but the drilling to define a resource is exploration drilling, which are done by a slightly different equipment type. So they're exploration drilling, diamond drilling rigs that are used, or air core rigs and the like. When it comes to production rigs, they are shorter holes, much shorter holes. Exploration rigs can be quite deep, several hundred meters at certain times. For when you're mining from a drilling for a blasting purposes, they're actually much shorter hole depth. They can be up to 15 meters long. They can be slightly longer than that, depending on how deep each of your mining bench is. So we talked about the walls previously, and in the walls, if someone sees a picture of a mine, you have what's called a crest and a berm, and each of those berms, flat spots, and to the next one is a bench. And so that bench is where you actually start your digging and mining. And that mining is done with broken ground. So you initially have to prepare your bench so your drills can go in on top of it. So you have to smooth it and grade it and level it. Then your mining engineers or your drill and blast engineers will design a pattern. In that pattern, you've got a production rig that does the drilling in a certain size and shape, and then you fill it with explosives. And that explosive is then carefully measured, monitored, and then you blast the material. During blasting, there's no one present close to the actual event. So it's quite a well planned and executed function of taking it from drill through to blast. Once it's blasted, it has to be checked. So a drill and blast supervisor and or the crew will go close to where the blasting has taken place and will be actually checking for any misfires. So sometimes explosives don't necessarily detonate, and in which case they have to be carefully removed and actually have to be put into a different area and dealt with separately. But that's kind of the process you go through up to the point of where a blast is actually then approved for the digging equipment to come in and start digging. Once you start digging, you can then start to separate out, okay, this part of the blast is ore, or these buckets, these ones are waste. That's where the grade controller function comes in. So there are many different roles that are very, very close to where the digging action taking place that has a input into how this activity takes place.
Mm. And then what happens to what happens to the ore and what happens to the waste once they've been loaded onto trucks?
So once the material goes into trucks, there'll be a dispatcher that would actually assign that material to a certain location. We talked a little bit about the waste dumps previously. So there'll be some material, if it's waste, goes to a particular waste dump, and it would be safely stacked there and maintained. That waste dump will have its own design and characteristics. The ore will go to a primary crusher. And so in the Pilbara, typically in your iron ore mines, you would have a primary crushing and a secondary crushing units. And so this is to take the very large pieces of rock, sometimes up to 1.5 meter type size, and break that down into smaller size. And then eventually that'll go through to the secondary crushing unit. So these are really taking large pieces of rock and breaking it down into smaller size rocks that will then actually go into your process plant through conveyor belts. So first act is design. Then you do the development, which is leveling out the bench, and drilling. Post-drilling, you've got the explosives and blasting, digging. Then from the digging, you either take it to the dump or to the crusher. And once it goes through the crusher, it then goes through to the process plant. It actually then gets all the impurities and the like removed. So, for example, in iron ore, you've got some shale that's contained with the ore. And so the shale then gets washed off, and the ore is what's left behind and stacked on stockpiles at the yard. Trains will come in, and then they will take the material away and through to the port. From there, other stockpiles will be maintained such that you can send out a final product out to the customers by ships.
And so within iron ore, the processing is generally quite simple in terms of crushing, grinding, so compared to, say, copper, where it might
typically
be a bit more.
Typically in copper, you have flotation, and you have to use some chemicals to liberate out your minerals. Whereas in iron ore, it's really your crushing and grinding, and then followed by washing. There are some complex processing activities, but largely it's really about liberating the ore from the waste, separating the ore from the waste, and the shales are washed off, and your ore, it's either use certain different processing flow sheets like crushing, density separation, and that's how the actual material is separated.
Yeah, at least on the hematite side, right?
Certainly in the hematite.
Magnetite,
it's a bit different.
Slightly different thing.
Yeah,
excellent. And then I guess how do we get better at mining? We've got the topic of performance improvement here. So we've got this process which is highly specialized, very detailed, involves lots of different moving parts and people with different skills. So how do miners get so good at doing that? As you say, with the Pilbara, it's a huge system of working extremely efficiently to produce iron ore at a low cost to the point where it's economic to transport it halfway around the world to China, to lots of different places. And for a bulk commodity, that's quite remarkable in many ways, that you can have a system that's efficient, that is that efficient, that we can move it all over the world. So how do the miners get so good at that? What's their secret?
And I think the real art in all of this is, how do you set up a culture in your organization such that continuous improvement becomes part of the ethos? And I'm a believer that if you are standing still and just, dare I say the word cruising, in other words, just maintaining status quo, it's actually not going to be enough because there are always things that are changing and mines have to adapt and adopt to those to be able to cope with those change. But part of that is the continuous improvement. So, if you, because we're dealing with such a variable nature of the work with the multiple different parameters that can have an impact on the outcome, not everything always goes smoothly. And in fact, one of the indicators is for a mining organisation, as per the metrics you just mentioned around operating cost, it's also about what product and what grade and what material are you actually supplying to your customers. Are they happy with what you have delivered? Is it consistent with the plan that you initially crafted to deliver that ore? So unless you're monitoring and measuring those particular metrics on a daily basis and then acting on particular trends, then you really are, can have a random outcome. And so a continuous improvement and performance improvement is really, really important because you're not dealing with certainty. It's not like, and then I know this will be a debate that goes on forever around the difference between manufacturing and mining, where, from my standpoint, I view manufacturing as largely dealing with sort of known aspects. You've got a fixed infrastructure, you've got a product, some widget that you're making, etc., that has a end point. Yes, there are market dynamics that can change, and your raw material might be, slightly variable, but you're not dealing with uncertainty all the way through the value chain, which you have to do in mining. So performance measurement, continuous improvement is a really core aspect of any mining company, because without understanding why are you deviating from what you expected, you're never going to be able to identify improvement actions to close that gap.
If I've got this right, so maybe with manufacturing, the parameters are a bit more constant. And perhaps this is also true of metal processing as well, thinking about an aluminium smelter, and dealing with a relatively fixed process with inputs that are generally quite consistent. So in the case of the aluminium smelter, you have alumina. With mining, and if you translate that across, I guess, air conditioners or textiles, you have particular pieces of machinery, particular processes for those things, but everything is man-made, so it's much more constrained. Whereas maybe you want to push back against this or spin it slightly differently. But with a mine, is every mine unique? It has, because it's part of nature in itself. Does every mine have to be set up slightly differently? You can't make it as a pure, say, cookie cutter.
It's not a template.
Yes.
There are aspects of a mining processes that you could replicate. For example, there's primary crushing, secondary crushing units, certain size, shape. Yes, you can have similar kind of design. In reality, when you're actually opening a mine, the shape and size of every ore body is different.
So that crusher, that grinder will be in a different location.
Exactly. Yeah. You also have, as basic aspects as your weather conditions are very different. So you might have an area which has got a very high rainfall or got seasonal variability. I know in Southeast Asia, there's a number of the countries' operations actually managing water from rain and deluge is actually as critical, if not more, than what you're actually mining from the ground.
Yeah.
So, you can't really mine with wet feet is the term that we typically use. So you've got to manage water. So sort of going back to the aspect of certainty, and that variability in mining presents a lot more challenges that you've got to be able to work with and have contingency plans and the like. Whereas in manufacturing, perhaps those constraints are a little bit less, I suppose more limited. I'm sure manufacturers will argue the point.
We don't want to offend the manufacturers too much.
No, very important. but and in fact, you can almost kind of put it back into the mining context that steel mills, for example, you could argue that the material coming into the steel mill can be seen as, okay, then it sort of starts a bit of a manufacturing process. Well, steel mills will often argue that the variability of the material that miners deliver can actually create some downstream aspects for steel mills. So I'm sure manufacturers also have similar issues, but it seems to me that in mining there are more variables associated with your ore body, your weather, your equipment, your maintenance, your breakdowns. All of these can be managed, but it requires stockpiling. It requires buffer stocks. So to manage those kind of variability, and sometimes you might have some more equipment, but that equipment costs a lot of money. So you can, if you pay for it, you can buy certainty to a large degree. But there's a trade-off between, carrying risk and providing something with certainty.
And interesting. So maybe we could say that continuous improvement process is different in mining to manufacturing. Maybe a car company changes the door handle slightly to use less material and saves $1 on each car.
Yes,
and so they're constantly trying to improve their process, and you scale that dollar over hundreds of thousands of units, and you've got a much larger number.
I can perhaps Ian, I can touch on a couple of examples that might help with the understanding of this concept of continuous improvement. So let's take a couple of areas. So I'll touch on safety, and I'll touch on productivity. So safety is it's a core value for majority of all mining companies worldwide, because the ethos there is that we want everyone to return home safely every day at the end of their shift. But sadly, that doesn't always happen. It's a high hazardous environment. It's got many hazards present. And so therefore, we have to have controls in place in mines to be able to deal with these hazards. And one of the main hazards in an open pit mining environment is light vehicle and heavy vehicle, or this big truck interactions. And there's been many serious incidents and sadly fatalities that's happened as a result of these two. So what does continuous improvement in that area look like, or what does improvement look like? And I think it comes initially from the recognition that that's not acceptable to hurt people. And then you sort of put processes in place. Yes, there are certain rules you can put in place to separate out light vehicles from heavy vehicle, but then some organizations have gone the next step and said, let's take human beings out of the equation altogether. And so trucks were then trialed with autonomy. And I think I mentioned previously about the autonomous trucks running in the Pilbara and other parts of the world. Well, they actually came in from the perspective of a couple of different areas. One is safety, no doubt, that by moving a person away from the vehicle eliminates that risk. But secondly, it also comes to productivity. So there's safety from just applying automation and autonomous technology on trucks, you've got to still be able to implement that technology in a way that it actually integrates well into your mining environment. So it's not a case of just taking a driving truck out and replacing with an autonomous truck. There is a change management piece that goes with it. It's a topic for a separate discussion, but that's one aspect of it. But then, of course, once you've got autonomous vehicle, you actually improve your productivity, and the reason for that is when you have a person in a truck during shift change, during crib breaks, which is your lunch breaks and the like, your equipment is actually not operating. Whereas when you're actually having an autonomous truck, your equipment is delinked from your human interfaces. So there is a classic case here, an example of where both safety and productivity is actually improved through a change in technology and innovation. But that comes from a continuous improvement mindset.
Yeah. And what are some of the tools, I guess, aside from safety, if you go into a mine site, what do you think about in terms of reducing costs or I guess increasing the productivity of the mine site overall? What are some of perhaps the first things you'd look at in a PI review or a performance improvement review?
Performance improvement review. Well, it really depends on where some of the concerns lie. If it is around production targets, then you've got to really come down to that flow all the way from understanding what you're mining to your schedule and your delivery, and what are some of the waste, dare I say. So it's using some of the lean methodology so that you can actually identify where there is waste in the system. And that waste is not just waste material. This is waste in terms of time, in terms of effort that is being put in, but you're not getting the result. So you really got to do a deep dive into understanding, well, what are the gaps between the expected outcome to the true outcome? And at a mine site, that would typically happen on a weekly meeting where people will actually look at that information in the past week before they can actually, agree to what's happening in the following week. So a weekly plan is a good way to reconcile. You used the word reconciliation previously, but that's kind of an approach to understand performance. There's also deep dives into areas like, and we talked about safety previously, but the safety incidents have to go through, particularly the significant incidents, through a taproot type investigation where you go really deep to understand the whys. What led to a control failure. So these are some of the tools and systems you can use. The 5 whys is quite a common tool where you can actually start asking those questions and then get to the point where you're dealing with the root cause as opposed to just with the symptom.
Yeah. What are the 5 whys?
Yeah, it's really just asking the questions 5 times.
Right. Okay.
You ask the first question and you get the first response. Then you sort of dive a bit deeper. So if this is what happened, why did it happen? And then the response will come back. And that response you take in and say, well, okay, what caused that to happen? Why did that happen? And then why did that, and so eventually you might find that, this is an example, that you had an incident where 2 vehicles had an interaction, might actually come back to the fact that a person had really poor sleep for the last 5 days and the fatigue had actually built up to the point where you actually now have an incident at your site today, just as an example. So that's kind of one of the tools and methodology. Just going back to the performance measurement, but also performance improvement culture, it actually has to go all the way in the organisation. Can't just stay at a weekly or a monthly level of attention. It really does need to cascade up the organisation to ensure that what is actually going on the ground from a let's say, production standpoint is well understood at the decisions that are made at the highest level in the organisation. And majority of the mining companies run quarterly reviews or half yearly, and then of course at the end of the year there's an annual plan. And majority of organisations run with the annual planning process whereby they can actually assess performance and then measures and metrics to actually track and to improve.
So there you're talking about, you've got very specific things that happen at a small scale and at a very specific point in time, and then I guess scaling them back up to the broader mine plan, to broader company strategy over longer periods of time. I guess almost the opposite when you've got a mine plan for a project, a new investment, and then you're scaling that down to the shift level, then you're going back up from the shift level, from a very localized level back up to global, regional.
And it is a very much a continuous process. So planning, if we go into planning just briefly, it starts with a strategic plan. In fact, majority of organisations will start with a goal and a purpose and a vision, but that is underlying, what's backing that up is what is your commodity that you're selling. If I could bring it back to that in a mining context, that needs to be well known. So a strategic plan will say, what have you got in the ground and how do you actually planning to extract it and then to process and sell it? Because that's the first thing. So that's a strategic plan. Are you mining from the right place at the right time? That gets to the next level of detail. So a strategic plan will come back into a life of mine plan. So, okay, well, if you've got a certain resource and reserve, well, how long is this going to last for? Which means how much capital can I inject into this operation or in the ore body to recover my expenses? Well, that gives you an idea about how long this mine's going to last for. Then you've got to bring it down to 5-year plan, annual plan, quarterly plan. So it's a cascading. And then as you understand more and more about that ore body, and in some cases, an ore body might be defined but not necessarily limited. So there may well be extensions of an ore body, or there may be a discovery which is close to that existing ore body that then suddenly changes your strategic plan and outlook. So this is a very much
more uncertainty to work in.
True, more uncertainty, but it also gives enormous confidence to your board and to your executive committee that that there is a opportunity to really extend mine life. And extending mine life adds enormous value, not just to your shareholders or to the company, but to the community that you're operating in. Closing a mine is a big deal, particularly the ones that run for 15, 20, 30 years. There's a whole community that actually is reliant on it and are supporting it. And so that is a consideration majority of mining companies need to take to say, well, how do I keep extending mine life, making sure that you're doing it in a safe and responsible way.
So PI is getting us closer. This mine is like an evolving organism rather than a sort of more fixed piece of machinery. As the pit gets wider and deeper, that things have to change and that the plan has to evolve, but that there's both downside risks and upside risks to deal with and to incorporate into that. Very interesting. So mining obviously has a big impact on the land, on the environment. It's inescapable. The very nature of it means that there has to be some impact. But I guess mining companies think more about how they minimize that impact and how they can, as you were just describing, be more connected to communities and do that in a way which is more aligned to social, environmental goals. So tell us a little bit about how ESG has become bigger in mining, or how that works within, say, some of the larger mining companies.
Yeah. It's a very important aspect, ESG. We talked a lot about the details of mining, but to actually operate a mine, it requires a number of approvals that needs to be in place from an environmental standpoint, as well as from a community and ethical standpoint. So the values of an organization is incredibly important. That is then tackled in or actually monitored in the governance aspect of the ESG. But coming back to the importance of it, mentioned about flora and fauna studies that we have to do around environmental protection of the land that we operate in. And that's not just the footprint or the act of mining, but it's also the landforms that we create, the roads and the network of infrastructure that has to be in place. If you then combine with the more recent actions against energy and emission reduction, that is actually a very key aspect of the E part of the ESG. Mines have to continuously look for ways to reduce the emission. That is typically as a result of running large equipment with a lot of diesel fuel. From a social standpoint, communities, Tom Price being one, where we, the organisations operate close to those kind of mines, cities or towns, have to be very conscious about the communities that they operate within. And not just the pure act of mining, but it's all the way along that supply chain. So there are individuals, we talked about the Pilbara, but a lot of support comes out of Perth and other parts of Australia, and actually from international support services as well. So ensuring that those communities are proactively engaged even well before mining starts and through the period of mining and post-closure is vital, is incredibly important. And there'll be a couple of examples that we can share there in terms of why this is important. So in 2019, there was a very horrific incident that happened in Brumadinho, Brazil, where there was a tailings failure and disaster that eventually 270 odd people lost their lives, and some of them are still missing out of that particular event that took place. Actually reinforced the importance of ESG in this mining sphere. Few of the sort of industry bodies came together and really developed a new standard for tailings management.
What was some of the factors that contributed to that disaster?
Look, there was it's again a topic for a deeper topic for another discussion, and there's lots of reports have been written about it. But in a nutshell, it was an existing tailings dam that was at the periphery of the operating environment, typically around stockpiles for a mine, and at that particular mine site in Brazil, this particular tailings dam, and there's some very incredible footage of the actual failure of this dam that flows like a river, a mud of river, through the actual stockpile area, out of the mining lease into the surrounding villages that then flow into a river system downstream. It's an incredibly tragic event. But it actually reinforced the aspects that you can't operate some of these features that's with the mine site without some good governance and standards. So ESG is a incredibly important feature of any mining operation and organization. The governance aspect of it is, again, a very important feature in the sense that you've got to measure, monitor, and report. So transparency of what is being, how you've gone about mining and producing really has to be reported regularly, and feedback needs to be also encouraged and appreciated by organisations such that they can actually improve. But
well, you can't manage what you can't measure. Right?
Can't manage what you can't measure. So yeah, and it's going to be more critical in the future as the world grapples with energy or emission reduction, and certainly the Brumadinho incident resulted in the standard that now majority of the mining companies have, large organisations have committed to, and therefore that will strengthen the mining community further. It does raise a question around ESG, and it's how well is it actually, let's say, how well is it actually implemented across the globe? Yes, the large organisations, the ones that are listed on the stock exchange and the like, have a responsibility and are, and then they are being monitored and challenged and expected to comply to their own commitment. But then there is also a number of mining companies, a number of mines particularly, in areas where those jurisdictions are perhaps weaker. And so, to really improve all of mining, everyone needs to get on board to the point where, that you're not differentiating between, whether or not you're in a developing nation or advanced, or in a area where there are challenges to produce.
So it's a very complex topic. I think ESG spans many issues from emissions, which is a global issue that's connected to energy and power, but then deforestation, tailings, all of these. There's downside risks. We spoke earlier that how vital mining is, and those minerals are used in everything that improves people's material standards of living. And we spoke about some of the ripple effects of that, where you've got large volumes of iron ore going to China. The steel that was produced there has enabled urbanization over the past 40 years, from a very rural economy to an industrial powerhouse, which produces almost all of the devices and many of the goods that we take for granted today. So there's huge benefits, and then how does the mining industry mitigate some of the externalities, particularly with social media as well, and the speed that news travels around the world. An incident like that can be a big issue for the reputation of a large mining company, but it's also it impacts communities on the ground. I guess with preventing major hazards like tailings failures, and remediating land, what does good look like there? Are you able to tell us a little bit more about those issues?
Yeah, sure. Look, I think the key here is about transparency of what's actually happening on the ground. So, what risk management is a very, I suppose it's an embedded theme in any of the mining operations and organizations. So, good risk management is where your frontline operating staff are actually monitoring what is happening in terms of deviation from expectation and reporting it so that you can actually then, analyze it and improve it. Then if you take it a step beyond, for major hazards like geotechnical, process safety, where you've got large equipment that might have a massive impact if it fails, or explosion and the like. So those major hazards, wall failures, tailings, process safety, are risks that really have to be assessed at an arm's length from the actual operating environment. And the reason for that is, and there are terms that we use in the industry, the 3 lines of defense, where your first line is really your operating environment, the teams that are on the ground. Your second line of defense is really done through an arm's length from operation, perhaps through a central team that will bring in some experts and say, let's do a deep dive around a particular topic that we might be curious about. How well is it going? Are there some gaps? What can we do to improve it? And then there's a third line of defense, which is really external, that is invited in from, auditors, for example, in a finance area, comes in and actually reviews and looks at the underlying risks and the impact. So, the underlying risk and then the actions that need to be put in place. And when you put it all together, that's how you can do a good risk management process for some of the areas like major hazards, and then to actually follow through on it. So one thing is to review it and develop the actions, and the commitment there is that yes, now you need to actually do all, work through the actions. Not everyone can do all the actions at the same time, so you got to prioritize it, but you've got to work through it so that you're actually continuously reducing the level of impact from the risk on an ongoing basis.
And then say, picking on maybe tailings, what does good tailings management look like versus bad? What are some of the to a layman economist like myself, what does that look like?
Look, I'm not a tailings engineer, but I have been associated with the recovery, or not the recovery, but the response to the Brumadinho disaster from one of the organisations that I worked with, and really what one of the aspects of tailings that is a little bit challenging is that it typically predates four long life resources. So some resources are being mined for more than 50, 100 years, that you actually have lost the knowledge. So every time something is put into a tailings dam, it's covered over. And before you know, you don't really understand what is the feature of that tailings dam. And when you have a tailings dam that has been there for a long time, you're really relying on monitoring equipment to be able to, and inspections and indications of any shifts in its properties of the tailings dam to understand what is the impact. So, but does that mean that you don't manage it? No, that's not the case at all. The monitoring has to be put in place, sensors have to be put in place. In some cases, you have to do some material science and property assessment to understand a little bit about where some of the potential weak points might be. You've got to ensure that the water can be managed. Surface water that comes off rain and the like has to be dispersed in a way such that it doesn't have pooling in certain areas and can create weakness. And so that innate understanding of the tailings dam is a good practice. Now, then, next comes the question of, well, in the event that there is a failure, where could this tailings go through? Like, how far can it run? You know, what would be the pathway? You know, are there people and environment and in the line of fire of these tailings discharge? You know, and then communities have to have prior warning so that in event of a failure, what do we need to ensure that how soon can the community be made aware of, such that any community close to that particular tailing storage can be evacuated and moved such that no lives are lost. So this is really about at a strategic level. That's what a tailings management needs to take into account. And then, of course, on a day by day, the tailings engineers and professionals have to keep good record of what is the material going into the tailings, where is it being stored, and almost build like a model of the tailings storage facility. So any tailings dams that are being built from now on for the organizations that have actually implemented or have committed to the global industry standard for tailings management will develop that model of what and build the picture of what's in the tailings dam, so that 50 years down the track, people can actually look at it and say, okay, we know exactly what's in there, and therefore we know what the risk is around particular aspects.
Some fascinating stuff in there. So I think if I've understood correctly, you've got one which is again dealing with uncertainty. So,
Yes.
so the legacy issues
Yes.
of not having kept data on what goes into that tailings dam, and then going forward, there's some consensus to put standards around that.
Yes.
There's also technology solutions
Yes.
as well. The second point you made really fascinated me, which is having a plan for management as well as prevention.
Yes.
So I remember quite clearly in 2011, 2012, when the nuclear industry had
Yes.
this revelation. They were very, very focused on prevention.
Yes.
And when Fukushima happened,
Yes.
one of the lessons that they learned from that was that they also need to think about management. So if something bad does happen, how do you make it less worse? How do you manage that situation better?
Yeah, and in some of these events, not sure, Ian, if you've come across the term the bow tie from a risk management perspective. No. So you have an event that takes place. Well, what are the parameters and drivers that leads to the event? And then subsequent to the event, what are the controls you need to put in place such that you minimize the impact on downstream? So that is a risk management tool or a process that a number of mining organizations use, or just not mining, but other organizations, to understand what is the drivers, and then what do you do to control downstream post the event. So that's just another technique on how we manage risk.
Yeah, fascinating. And I think we can't really talk about ESG without emissions.
Yes.
And emissions are a very complicated topic, and I think they're viewed in a certain way in Western countries, and in the developing world. There's also views about them as well. They have to trade off safe, reliable sources of power. So you still have a lot of build out of coal, particularly in Indonesia, where we're very close to here in Singapore, and a lot of that is connected to the mining industry, connected to the nickel and aluminium business, and so there's big global trade-offs there, and emissions are very complicated because they flow through supply chains. So it's not just the upstream, it's downstream as well through mineral processing, say steel making in the case of iron ore, but then manufacturing. I think something that's quite interesting, which been doing a bit of work on recently, is about the consumer and their role in pushing for better standards in general. So obviously better awareness of broader ESG issues, but then in the emission space, can you have lower carbon products? Can you have lower carbon metals? So the idea of green nickel or green steel or green aluminium is something the LME is looking into at the moment. It's something that steelmakers are looking in, trying to build those value chains of the future. And obviously the upstream is a key part in that. And I guess maybe the question I'd have for you is what does a carbon neutral mine look like? We've talked about autonomous trucks.
Yes.
What about electric trucks? What about
yes, definitely.
renewables, particularly in a jurisdiction like Australia, that there seems to be a good fit for using renewables. So I'd love to hear your thoughts on that.
Yeah, look, it's an evolving space, but there's no doubt that there is a commitment by a number of the major organisations to being either net zero or fully eliminate emission 2030, 2050 type numbers. I think the key here is, well, what's the action on the ground? And we're definitely seeing progress in renewables. So solar is and wind turbines are now part of the energy reduction strategies and tactics. And then if you bring it back to the mine side, you talked a little bit about you touched on electrification. That, in my mind, is actually the key to replacing the diesel. So the trucks that we talked about previously in a mine, you've got 300 plus autonomous trucks, 240 ton plus type size, burning or using significant amount.
How big is a 240 ton truck?
Well, it's
like the size of a house or a building.
It's a small apartment block.
Right.
No, well, it's actually more like several townhouses put together.
Yeah.
It's kind of like the size, but it's enough that it's big enough that if you're standing 50 meters in front of the truck, the operator at the truck, well, if there is one, although if there's no, if it's autonomous, then there is no. The truck will stop because they'll see a object.
You got a sensor.
There's a sensor, an object. But in terms of like up to 60 to 70 meters away, you will be able to see it. So you can imagine how high you are, that if you're inside the shadow of the truck, 70 meters, 50 to 70 meters, then you won't be visible to the operator.
That's enormous. Huh?
So that just gives you a bit of a sense of the size of the trucks. But the trucks they consume a lot of diesel, so there's been a lot of effort put into how do we minimize that. There's been a number of different technology that's been trialed and tested across the world. Again, the challenge there is, well, who's taking the lead? Is it the mining companies? Is it the equipment manufacturers? Ultimately, it has to be a partnership. And it's through those partnerships that we have to bring not just a single organization with a single equipment manufacturer, it's actually creating consortiums. So, 20 years ago, if you said two competing mining companies would be collaborating on a certain solution in the industry, it would be a bit far-fetched. Today, it's the norm. Because you can't solve this problem by yourself. No one individual or one organization can solve it. It'll take a team effort. So that's where, for example, truck electrification there are several different equipment manufacturers, several companies are testing one. On our competitor side, they will test others. There'll be a exchange of data to see how well these electrification solutions have actually worked or not, what improvement needs to happen, etc., etc. I feel like we will be heading more towards electrification, but mining poses an enormous challenge for electrification, particularly around batteries, because batteries have a fixed life before it needs to be recharged, and your mining environment is such that you've got 15, 20 kilometer haul distances for, let's say, one of the cycles. And when do you actually charge your battery? And when you charge your battery, you are not moving material. So therefore there is downtime of the equipment. Therefore your capital cost goes up because you need additional equipment to deliver the same amount of material. So the solution there is, how do you charge your batteries as you are actually hauling? So, most of us have probably seen trolley systems in trains and trams across the world, whereby you've got overhead trolleys. That's one of the solutions.
So is this the reason why the solution has to be a collaboration between the miner and the equipment manufacturer? It can't just give you an electric
This is not a
truck.
case of here's a truck with a battery in it, go for it, because it won't work. It needs to have a system that goes with it. Trolley being one, there's inline charging, there's induction on the road, there is different methods that's been tested and trialed in how do we charge the truck during its continuous mining process such that it can effectively still be utilised and at the same time reduce its energy footprint.
Yeah.
So that's just a very minor issue, but it's not minor in the sense that it's not an easy. It's a complex problem to solve. But organisations have accepted the challenge, manufacturers have accepted the challenge, and the industry in itself is moving forward. Now it's a case of scaling up so that one or two trucks is incredibly important to test the technology, and then they've got to find a way, or we all have to find a way, to how rapidly can this be scaled up and economic in a sense that everyone will accept it and take it on.
Yeah, makes sense. So what perhaps does a mine look like in 20 years' time, or what does a large mining company look like with automation, with robotics? Maybe it's electrified. How do you think that will play out?
Yeah. So look, a mine in 20 years is going to look different, evolve a lot from where we are today, because a lot of the technology we've discussed today are already starting to become common industry standard. Autonomy is now well established and improving. So that's an area that I think it's just going to get more advanced in a few years, let alone 20 years. But safety, for example, will be one feature. Like in 20 years' time, it'll simply be unacceptable to have injuries and major incidents at a mine site or an operation, let alone, like, dare I say, fatalities will not be accepted. So how do we do that? And yes, you can remove people from mine sites. I think the footprint of individuals being at a mine site is going to be a lot less. There is likely to be your closure and your rehabilitation plan is fully integrated into the way you mine, such that it's not a case of we'll deal with that later, which perhaps was the way that this whole aspect of closure was dealt maybe 20, 30, 40 years ago. Certainly not today. One other area that I think is going to be exponentially different is how do we use technology, particularly around data. And artificial intelligence is going to be used, and perhaps we'll move on to AI version 5, 10, 15 by then. In what does that look like? I don't know. But what I would say is a lot of the variability that we see in mining today is likely to reduce, which means that the material flow all the way from the ground through to the customer is going to be more consistent and more reliable. Whether or not that actually still delivers value to all of the different investors along the way, that's a different issue. But in terms of a consistent and a well-performing mine, in 50 years, you're going to see more mines delivering to its promise. So technology, automation, less workforce at the site. I think the skills are going to be different. You know, the type of work is going to be different. So it's going to be the work is going to transform more into knowledge-based systems and more around insights, as opposed to spending a lot of effort collecting the information. It's about what do we need, how do we make better decisions. There's some of the aspects that I can foresee to the future.
I guess connecting it up with the ESG bit and I guess green supply chains. For me, one of the core issues around getting green premiums, whether it's in steel or whether it's in aluminium,
yes,
is transparency.
Yes.
And understanding, obviously, commodities, or maybe not obviously, commodities can be, they're highly interchangeable at certain parts of their processing. So a copper cathode can be exchanged for another copper cathode, for instance, and this makes traceability challenging. So on the green side, you've had you've got instances where consumers will pay more for organic food. They'll pay more for free range eggs, where they have confidence and trust in those supply chains being better. I guess from a ground mining engineering perspective, is that traceability something that's possible in supply chains?
Yeah, it's already in place in some areas. Certainly, once you take it into a stockpile, and I'm just getting down to the real facts here, that once you mix material at a mine site, yes, you know exactly where the materials come from. Once it goes into the port, you're starting to mix material from different regions, but from the same jurisdiction. So, for example, the ports in the northwest of Western Australia, you'll have a fair idea that that's material out of the Pilbara, largely, or even inside that one mining company. Some of the organisations are now starting to build port-side stockpiles so that they are a little bit more closer to the customer in terms of blending and providing the material. Even that can be tracked back. So they, okay, we've got supply from, let's say, Canada or from Africa or the like, or other parts of the world. Yes, you can track that. Or once it gets beyond that, it's when you start to mix multiple countries and different organization, it starts to dilute that aspect of traceability through to the source.
Because obviously a steelmaker will take iron ore from different sources. for a number of reasons.
For a number
right?
of reasons.
Yeah,
And
quality,
yeah, being
diversify their risk,
and
but also to capture some of the value of blending.
Absolutely. And I mean, you can't just take all the from a customer standpoint, if you take the highest grade material and paying a premium for it, you want to blend it with some low cost product or raw supply from perhaps your local suppliers. So once you get to that point, you start to then lose the integrity of your source. But that's just in one of the commodities. Perhaps are different ways to be able to track by looking at the product chemistry and then tying it back to, okay, if this is the range of the outcome, then we know that it has come from this particular resource. So that's how that. Now, whether or not.
So will every iron ore product have an almost unique chemistry?
Not every iron ore, but regions will have a certain indicators and markers that you could use to say, well, actually, this is where it's come from. But whether or not, I don't see a case of each mine being unique, because it's all part of the same system in terms of the geology is consistent in the Pilbara. You can actually track the geology in Newman or, in one part of the Pilbara to Tom Price. It's all part of the same chemistry when it comes, chemistry, but it's the same sedimentation process over a period of time. Yeah,
got it. And so what does the career of a mining engineer graduating in 2026 look like? What skills do they need? What does their career look like in this brave new world?
It's an interesting question. I mean, mining engineers are graduating with a lot of the current skills required, particularly around technology, data, coding. I think one of the key features of mining is it is an industry which relies on very, very proactive and ongoing communication, internal, external stakeholders. So the softer skills is absolutely vital.
So they need to be nerdy and have good soft skills as well.
They have to be both. Yes, you can't just have one, because a number will give you an idea. You've got to communicate and actually bring people along the journey. So the soft skills are not something that typically you learn out of university. You learn at a work environment. So my view of a 2026 graduate is they need to spend time on the ground. Particularly in a mining, you can't learn mining by sitting in an office and just looking at a laptop or a desktop or a set of data and metrics. You've got to actually go and touch it and feel it. So getting on the ground and actually experiencing very different roles is vitally important. Absolutely data savvy and is I think a core feature of a mining engineer. But so is the ability to connect across that value chain, internal, external, is vitally important. And being more curious than the problem at hand as to the impact that person can have on a much more strategic level.
And so the engineers will be different. The mines will evolve and be different, and perhaps the companies themselves as well will look different.
Definitely.
So I guess what does organizational change is something that you're quite familiar with. So what does that look like in a large company?
Yeah, look, with some of the changes that we've discussed, ESG being quite an important one, and it's not just a change where someone flicks a switch and suddenly something new happens. It's evolving over a period of time because expectations are changing from stakeholders on the responsibility for miners. So change in most organizations, there are drivers for the change. Yes, there's the economic drivers. When a market has a downturn, then organizations have to react to it, whether it's through cost reduction or pausing certain activities or not and not progressing with certain growth projects, etc., are all part of that aspect of the change. There's other change, which is a more positive change, which is the requirement for your product suddenly goes up because there's a supply chain issue somewhere else. So that then creates a much more aggressive, how do I accelerate from my current state to that need to satisfy my customers' requirement and take advantage of the issues in the supply chain. In terms of inside an organization, one of the big changes that most organizations are grappling with is the digital transformation and the change, where how do we use the petabytes of data that we collect through, like I mentioned about autonomous equipment, where they've got lots of sensors, and these sensors are collecting data every second. But how do we, and perhaps many gigabytes and terabytes and petabytes of data, well, how do we make sense of that? So that's not just a case of having a few smart people that are writing some intelligent programs to give you the ta-da, here's the answer. Well, actually, that needs to be validated, verified. There's a whole change process of understanding what makes sense of that information and then turn it into decisions. So digitization also has some challenges where some of the data is in an unstructured way, with the way it's collected and stored. So how do we...
In spreadsheets?
Yeah, in spreadsheets that may or may not have errors in it that people may or may not know about. So how do we take all of this information, all this data, into a structured way such that you can actually then apply proper change management in... a lot of people are quite concerned about, well, what's going to happen to my job if AI is introduced and it replaces what I do? Well, actually, that's all part of the change process that we have to go through as an industry to make people comfortable about the change, to find alternate, roles and all skills and work for individuals, such that, this change in digital transformation is embraced, as opposed to, the challenges that are often thrown up. And the reason for doing this is not just that you can make better decision and or reduce your costs or improve your profit. It's actually ultimately comes down to what's in the ground and are we maximizing the resource from the ground. It all has a link back to that. And so if you can eke out more, let's say currently, an example, if the current cost at a certain mine is a certain dollar per ton, but by using better decision, you take some of the variability and risk out, and therefore you can actually reduce your operating cost, which means you can probably take some more marginal material that extends that mine life for another 3, 5, 10 years. Well, that's huge in the context. So technology can actually help in many fronts. So that's a change that most are grappling with. And emission reduction is the other one that is front and center. Well, how do we introduce that and scale up?
Yeah. And I guess in these big global organizations, I've always been curious about the centralization versus decentralization, and the ebbs and flows between that. I guess it'd be interesting to hear your experience of how that looks within on the ground within the context of a large organization. And how are these the global miners? Why are they not just small individual mining companies for each mine? What's the value add of of the global miners, which have multiple assets in different parts of the world, and that corporate piece that bridges across them. What does that? How does that benefit?
It's a perennial question. This whole concept of central versus decentralization. It really comes down to the drivers that leads to that decision, and in some cases, standardization is the other word that often comes into the mix. How much do we want to standardize versus how much autonomy is actually allowed, and you can actually work this through in a very logical, rational way. So, for example, if you're producing similar material from different parts of the world but done in exactly the same way, then it makes sense to have a common systems and processes that can be applied. And so there's a level of standardization that you can build. Then the question becomes...
An application of best practice.
An application of best practice, because you can learn from each other and actually improve. And then you can apply that improvement consistently across all of your assets. But that's not always that simple because of the geography. There's enough variability in your particular site or asset that makes a standard system and process potentially not being able to be executed. Then you start to have degrees of freedom around that. And it all comes down to centralization, decentralization, all comes down to what is the size of the pool of resources and effort that you want to put into each of those areas such that you're getting the best outcome. If one becomes too large and cumbersome and start to operate in silos and it's almost self-serving, then you're kind of missing the big picture or the point around actually you are a customer to the assets to deliver the outcome. And vice versa, if you've got assets that are, say, decentralized, if assets have full autonomy, then suddenly you kind of are running a little bit potentially misaligned to your objective of the goals of the organization. So it's a case of where it makes sense to centralize, we should centralize because there's an opportunity of synergies and, there is, you're just effectively being more efficient. But then there are some areas where, for example, day-to-day running of the operation has to be close to the ground. So assets have to take ownership of all activities that happen at and around a mine site. That cannot be outsourced to the centre. And vice versa, the centre can't say to the assets, here's a daily plan. And within looking at like the first or weekly or even monthly, they're looking at it, a site person will just say, this doesn't make any sense because of this, and this. And you kind of go, well, it didn't make any sense to do that from, sitting in a corporate office or in a central location. So yes, there are ways to connect all the dots up that can make some of those kind of information gap less and narrow. And maybe in 2050, there will be an opportunity to remove all individuals from a site. And therefore, this whole concept of central, decentral doesn't really matter. It's kind of like it's an entity that's delivering an outcome.
Yeah.
But today it matters because you've got large organizations with many individuals who've got all specific roles. And it comes down to what's your operating model.
Yep.
And if your operating model is, central, then everyone has to get on board. And if it's decentral, then you've got to really reduce your center to the point where it's only those elements that has to be carried out in the center stays in the center, the rest goes close to the asset. So probably didn't answer that question exactly what you wanted, but just my views on centralized, decentralized. It goes in cycle.
Very interesting. It's a totally different perspective on decentralization, centralization, to perhaps the way I think about it. So it's fascinating to hear. I think the last question I've got for you is what keeps you interested in mining. You're here now in Singapore.
I am.
You've set up your own technical consultancy. What keeps you interested in this sector?
I mean, I've really enjoyed the conversation today, and so mining is something that I've grown up with, particularly after graduating from university. And what I find about mining is that no 2 days are the same. Every day in a mining context gives you a different perspective, and it always gets you to be curious about your own thoughts and perhaps biases that I have developed over time, and they are being questioned and challenged through learning more from what is happening today in the industry. There is the one big aspect of it which keeps it very interesting, and that's the natural variability of what's in the ground, and we covered that a lot. So every mine site looks different. Every mine site is potentially in a different setting, different communities. So there is no such thing as a template that you can rinse and repeat. And there is never. It is such a broad topic that there is no real, unless you go narrow and deep into one of the sectors, you're always finding interesting people, environment, people from different culture, background that you're engaging with. And that makes it, I enjoy working with people. So that's one aspect of it that keeps me interested. And then it's actually essential that we have mining for not just maintaining a standard of living that we appreciate very much and somewhat privileged to have that in the Western world, but also how do we actually make that available to the rest of the world? And let's ensure that mining has an important role to play in the future. And whatever I can do, whatever you can do, and others listening to this podcast can do to tell the important story that mining plays in society, that's really what's really important.
Fantastic. Let's leave it there. Santi Pal, thank you so much.
Thanks, Ian.
It's been a pleasure.
Great conversation. Thank you.
Market moves, I know the signs, nickel dreams and copper lines, spotlight shining on the ore, steel's got rhythm, I want more, heavy swing, feel the gleam, silver talks in a smoky dream, charts and mines, prize divine, dancing through that global line. From Rio nights to Chinese ports, metal flows and